Hello everyone, this week we're focusing on Cambridge IGCSE Mathematics, the topic of algebra, subtopic of differentiation. So coming to what exactly we're discussing about, differentiation is a key rule that you might have to learn throughout your mathematics life, and it is one of the key things that you will have to major if you want to do it in your further studies. So let's look at the basic. The basic structure of differentiation is follows, right? So generally, if you have a formula that is y equals to something, then we call the differentiated thing derivative. Okay, so that is the name here, dy by dx. That is basically the name given to the differentiated version of the formula. And how do we write a general rule? Well, the general rule is this: if y equals kx to the power of n, then dy by dx, that is the derivative, can be calculated by multiplying this power to the front. So it becomes k times n. And what you then do is you take the x to the power of n and you subtract 1 from the power. Okay? So that is basically how differentiation works. So if you were to do an example, okay, and we break this into 3 parts, 3x squared, when you differentiate, remember the 2 multiplies to the front, so it becomes 6, and then you subtract 1 from 2, so that becomes x to the power of 1. So we have 6x as the differentiation of 3x squared. Same way, you continue on. So negative 5x is basically like saying x to the power of 1. There's an imaginary 1 there. So you multiply that 1 to the front, and then you subtract 1 here. So this will then become negative 5, right? So we will then get it as negative 5x to the power of 0. So x to the power of 0, remember, is the same as just saying 1, the constant. And finally, what you always need to remember is when you are differentiating a constant, the constant will always disappear and become 0. So it does not get considered in the final expression. So moving on, if we look at another example, finding the gradient of the curve at y equals x negative x to the power of negative 1. Okay. So what actually dy by dx? What does dy by dx stand for? Dy by dx actually gives us the gradient formula, which allows us to calculate the gradient at any particular point on the line or the curve, for example. So here, if this is my curve, I can first differentiate it to find my gradient formula. So when I'm differentiating, when I differentiate x, it will become 1. And when I differentiate negative x to the power of negative 1, it will become x to the power of negative 2. Once I've done that, I can actually remove this negative power using indices rules and take it to the denominator. So I have 1 plus 1 over x squared as the derivative. I then want to find out what is the gradient. For that, I have to take the x value and substitute into my gradient formula. And that's what I'm doing here. So that is, my equation will become 1 plus 1 over 4. So that's basically 5 over 4. So the gradient at that particular point is simply 5 over 4. You may also be asked to find the equation of the tangent to a particular curve. Now this involves a few steps. So the first thing is you have to actually find the gradient at that particular point, right? So we have been given the curve equation. So what we first do is we start by differentiating the curve equation. So this then becomes 3x squared and negative 6x. So this will give me the gradient of the curve. So that is using my differentiation rules, right? Remember, multiply the 3 to the front, reduce 1 from the power. So x cubed will become 3x squared. negative 3x squared will then differentiate into negative 6x. So this gives me the gradient formula. Using the gradient formula and the x coordinate, I can then substitute and find out that the gradient value is 9. And that is a must when I need to find the equation of the tangent. So to find the equation of the tangent, I need the gradient, which I already have, which is 9. And I also have the x value, but I also need the y value. So an additional step that you have to do is you take the initial equation given to you and you substitute the value of x, which is 3, wherever there are x's present, and then you can find out the value of y. So the value of y, or the coordinate of point P, is basically 3, 2. Once you've obtained this information, you know that any equation has a line y equals mx plus c, right? That in any line has the equation y equals mx plus c. So for this particular line, you can substitute in the y value as 2, x value as 3, and m value as 9 as per the calculations, which allows us to find out that c has to take the value of negative 25. And by substituting all this in, you can then find out that the equation of the tangent is therefore y equals 9x negative 25. And this brings us to the end of the differentiation component in the syllabus. Alright, so let's finish off with a few questions. So differentiate 5x plus 1x squared. So remember, there's an imaginary 1 here. So it's basically 5 times 1, x to the power of 1, take away 1, plus 1 into 2, x to the power of 2, take away 1. So this will become 5x to the power of 0. And this is going to become 2x to the power of 1. And this is basically simply going to simplify to 5. And this is going to be 2x. So 5 plus 2x is this differentiation. So that is option number 1. Okay, question number 2. To differentiate this, so again 5 into 4, x to the power of 4 take away 1, plus 1 into 1, x to the power of 1 take away 1, and negative 5 into 0. Basically, when you differentiate, that is going to disappear. So this is going to be 20x to the power of 3 plus 1, and the negative 5 is gone. So this should be option number 4. All right, again, another differentiation question. So we include the negative here. So negative 4 into 3, x to the power of 3 take away 1. So this is negative 12, x to the power of 2. Again, option number 4. And the last example, so when we differentiate this, this is going to be 8 take away 12x plus 12x squared. Right? And looking at which one looks like that would be option number 3. All right, and that brings us to the end of the chapter on differentiation.
Subscribe us now for more videos and content.